In today's note, we're going to be looking at the Big Bang Theory, not the TV show, but the theory of how the universe came to be. So, the expanding universe. So, the universe is continuously expanding. It's filled with galaxies that move away from one another. So, Edwin Hubble first observed this when he identified individual stars inside the Andromeda galaxy and realized it was separate from the Milky Way. So, realizing that some of the stars he's seeing are separate from the current galaxy that we're in. He also observed that all galaxies are moving away from each other, and that the further a galaxy is, the faster it travels. So, in this image here, you can see all these different galaxies or stars in our universe. So the Big Bang. So basically all matter and energy in the universe expanded from one tiny dot. And there is a hot, dense expansion approximately 13.7 billion years ago. So 13.7 billion years ago, there was this massive expansion of matter and energy from this singular dot, is basically what the Big Bang Theory is. Here we can kind of see a brief overview or kind of a timeline of what the Big Bang Theory is. So basically, we'll just kind of read through them. In number 1, the cosmos goes through a super fast inflation, expanding from the size of an atom to that of a grapefruit in a tiny fraction of a second. So we know the size of an atom. We can visualize the size of a grapefruit. So imagine going from that increasing in size in a fraction of a second, the amount of energy that would be involved. So in the second one, and again, you can see the temperature associated with this, what they believe it is. So post-inflation, the universe is a seething hot soup of electrons, quarks, and other particles. And 3, a rapidly cooling cosmos permits quarks to clump into protons and neutrons. So here we're kind of getting the basic components of an atom forming. About 3 minutes after the Big Bang, it's still too hot to form into atoms, but charged electrons and protons prevent light from shining. So the universe is a super hot fog. 5, so this is 300,000 years after the Big Bang. Basically, electrons combine with protons and neutrons to form atoms, mostly hydrogen and helium, and light can finally shine. So this hydrogen and helium can start producing light. So 1 billion years after the Big Bang, gravity makes hydrogen and helium gas coalesce to form the giant clouds that will become galaxies. Smaller clumps of gas collapse to form the first star. So basically, gravity is pushing these atoms together. And then 15 billion years later, as galaxies cluster together under gravity, the first stars die and spew heavy elements into space. These will eventually form into new stars and planets. So as the stars die, they release heavy elements or new elements into space, and these elements then go on to form new stars and planets. So that's basically kind of an overview of what the Big Bang Theory is. So again, the universe was extremely hot and energy spread out very quickly. As the universe cooled, energy began to turn into matter, mainly hydrogen. And then over thousands of years, this matter became clumps, which eventually became stars and galaxies. So some evidence for the Big Bang: static interference, or static, is actually radiation or remnants of energy from the Big Bang. And there is the redshift. So this is stating that as galaxies move, the light they emit shifts towards the red end of the spectrum. Most distant galaxies exhibit redshift. So this is an example of what it is. So we have a close star. We use the light spectrum that it emits. So again, this can come from elements. We've talked a little bit about this in the chemistry unit. Each element kind of emits its own light spectrum. And so you kind of get that from stars. So what's happening is, if you were to get use a reference spectrum, say as the close star, and you compare it to a nearby galaxy or a faraway galaxy, what happens is the spectrum or the lines start to shift more towards the red end. So this is basically, there's a lot more science behind this that basically shows that this change of spectrum in light shows that objects are moving away. Similar to sound, if someone's walking away from you, the tone is different compared to when someone's walking towards you. So that's kind of the same thing, but instead of sound, it's light. And basically, the bigger the shift, the faster the light source is moving. To think of it as another analogy, there is kind of using a raisin bread analogy. So I'm not sure what it is with scientists and raisins and pastries or baking, but it seems to be a very common analogy. So basically, if you think of dough or bread with raisins in it, the raisins are at rest relative to one another in the dough before it's placed into the oven. So we make the dough, the raisins are in there, they're at rest, they're not moving before we place it into the oven. They're all stationary. As the bread rises, it also expands, making the space between the raisins increase. So as it expands, if they were close together, when the dough starts to rise, the raisins, or the space between the raisins, start to increase. If the raisins could see, they would observe that all the other raisins are moving away from them, although they themselves were stationary within the loaf. So if you imagine standing on a raisin or being a raisin and looking at everything else would be moving away from you, even though you felt as though you were stationary. Everything else is expanding or moving away from you. But in reality, only the dough or the universe is expanding. So basically, this is kind of an analogy of where this spectrum comes into play, or the redshift. So it's kind of something similar to that. So hopefully that's a little bit easier to understand, or at least kind of you get the idea of what they're looking at. So again, this is just a quick overview of the Big Bang Theory, or basically the theory of how they believe the universe came to be.